Ready to dive into some seriously cool tech.
Let's do it.
Today we're looking at ray tracing in Unity,
Oh, right.
and we've got some really cool research about how it's being used to teach computer graphics.
Yeah, it's not just about making games look good,
Right.
which it does,
Yeah.
but this is really changing how people are learning about computer graphics.
I'm all ears because, to be honest with you, I've heard the term ray tracing, but I don't really know how it works.
Okay, well, imagine you're in a room
Okay.
and there's a lamp.
Mm-hmm.
The light from that lamp bounces off of everything in the room, right?
Right.
It bounces off the walls, the furniture, you,
Yeah.
before it reaches your eye.
Right.
Ray tracing is basically simulating that process, but virtually,
Okay.
to create this, like, crazy realistic image.
Okay, that makes sense. But how is that different than what games usually use?
So most games use something called rasterization.
Okay.
And rasterization, it's more like coloring within the lines.
Okay.
So it's efficient,
Yeah.
but it has a lot of trouble with realistic reflections and shadows
Okay.
because it's not actually tracing how the light would behave.
So ray tracing is like ditching the coloring book and going for the real deal.
Yeah, exactly.
And this research actually shows the difference.
Yeah, so figure one in this paper we're looking at, it shows a side-by-side,
Okay.
and it is like night and day.
Wow, I have to see this. So if we break down ray tracing, what are the key things that it's simulating?
Well, this paper focuses on three things:
Okay.
reflections, refractions, and shadows. And they use this tool called the Virtual Ray Tracer, or VRT, to help students visualize it.
VRT. So it's not even just for making games, it's a learning tool too.
Yeah.
Oh, that's cool.
It lets students play around with all the different parameters
Right.
and see how those actually affect the final image. So it's like a virtual lab for understanding how light works and how we see it.
Okay, let's dive a little deeper into these concepts.
Yeah.
So reflections, it seems pretty self-explanatory, but I'm guessing there's more to it.
Yeah, you look in a mirror.
Yeah.
With ray tracing, the simulation doesn't just stop at the first bounce.
Oh, wow.
It can actually calculate multiple reflections.
Oh, wow.
Like, those infinite reflections you see in a hall of mirrors?
Yeah, it's always a bit trippy.
Yeah, and Unity uses this technique called recursive rendering, which essentially means it can track how light bounces around a scene realistically.
Ah.
And you can see it in figures 9 and 10.
Okay.
It's really impressive how much more detailed those reflections are.
So it's not just about making it look shiny.
Right.
It's about how the entire environment reflects.
Exactly.
That's amazing. What about refractions? That one's always kind of hard to wrap my head around.
So refractions are all about how light bends when it passes through different materials.
Right.
So the classic example is a straw in a glass of water.
Right.
It looks broken because the light is bending.
Right, like from science class.
Exactly.
Yeah.
And ray tracing can simulate that bending very accurately.
Huh.
Figure 11 shows the comparison. And the difference is huge. You get these really realistic distortions and caustics, like the patterns at the bottom of a pool.
Oh, like you're seeing the world through a glass of water, but in a good way.
Yeah.
What about shadows? Those seem like a small detail,
Yeah, okay.
but I bet they make a big difference too.
They can make a huge difference.
Yeah.
With ray tracing, shadows aren't just kind of like, blobs of darkness.
Right.
They have shape and softness, and they can be affected by the color of the objects around them.
Yeah. It's like those subtle shadows you see in real life
Yeah,
that you don't even realize, but they add a lot to the realism.
exactly. And the cool thing is with Unity and ray tracing, developers can control how those shadows look.
Yep.
They can fine-tune like how many rays are used.
Right.
More rays means more detail, but also more processing power is needed.
So it's always that balance
Right.
between how good it looks and how well it runs.
Exactly. But then they've got these cool techniques like denoising, which helps to smooth out the rough edges.
Okay.
And they end up looking really crisp, even with fewer rays.
Denoising, huh? That's cool. It feels like we're really getting into how Unity actually makes this work.
Yeah.
Speaking of Unity, how have they embraced ray tracing? It's not just a small thing they added, is it?
No, they went all in. They have this thing called the high definition render pipeline.
HDRP.
Or HDRP.
Got it.
Yeah.
So break that down for me. What is that?
So HDRP is a whole rendering system made for realistic graphics,
Okay.
and that's the basis for all their ray tracing capabilities.
Gotcha. So the HDRP is like the foundation that makes all the ray tracing magic happen.
Exactly.
Okay. And this isn't all theoretical. Are there games that are using this?
Yeah, so the paper mentions Siberia, the world before.
Okay.
It uses Unity's ray tracing,
Okay.
and it looks amazing. Figure 4 shows a screenshot,
Okay.
and you can see all the reflections, the lighting. It's crazy.
Siberia, the world before, adding that to my list.
Yeah.
But this realism It's going to come at a cost, right?
Yeah. Retracing needs a lot of power. You need a good graphics card to do all those calculations.
Yeah, I can imagine. My current computer would probably explode if I tried to run that.
Uh,
And the paper mentioned that Unity's ray tracing isn't available everywhere yet.
yeah, it's still in development.
Okay.
Like, it's not on Macs for web games yet.
Okay, so some hurdles to overcome
Right.
before it becomes like the standard.
Yeah.
And even within Unity,
Mhm.
are there compromises they have to make so that it runs well?
Yeah, sometimes they'll turn off ray-traced shadows on objects that already have reflections or refractions,
Ah,
just so it can run smoothly. It's about making choices for the best look.
that's wild. So they're like carefully choosing where to use ray tracing
Exactly.
to make it look as believable as possible.
Yeah.
But even with those limitations, this research shows a really cool use for ray tracing, besides just making games look better.
Yeah, they did a study where they had students learn about computer graphics
Okay.
using that virtual tool, VRT,
Right.
with and without ray tracing.
Okay, so one group's using the old way, one group's got this cool VRT thing with ray tracing,
Right.
and what happened?
The students using VRT with ray tracing, they just got it.
Yeah.
They understood how light works way better.
That makes sense. It's different reading about it than seeing it happen.
Right. And they could play with it themselves, really help them learn.
So it's not just how games look, it's how we learn about tough stuff too.
Totally. And think about it. This could change other fields, like architecture.
Oh, yeah.
Imagine designing buildings and seeing how the light falls realistically.
Right. Showing clients what it'll really be like inside.
Exactly. Or simulations. Think about pilots training in a real-looking cockpit.
Wow.
Or surgeons practicing with lifelike detail.
It's getting hard to tell what's real and what's not.
And we're just getting started. Better graphics cards are coming, the tech's improving.
Crazy to think. We went from those blocky games to this in no time.
It makes you wonder, what's next?
That's the big question, right? As this gets even better, how will it change how we see the world, real and virtual? Something to think about next time you're in a game or even just online. Thanks for diving deep with us into ray tracing. Until next time, stay curious.